2 or review section 2. So we're talking about real numbers and their properties. So when we look at the real number system, it's made up of subsets and sets of different types of numbers. So we first start out with natural numbers. So natural numbers are just kind of your counting numbers. So that is 1, 2, 3, 4, and so on. Keeps going on forever, right? And then outside of that is whole numbers. So whole numbers are just 0, 1, 2, 3, and so on. So natural numbers are a subset of whole numbers. So whole numbers are natural numbers are a subset, and natural numbers are usually with an n. They're a subset of the whole numbers. Okay, and then, but whole numbers are not a subset of natural numbers because 0 is not in naturals. Okay, and then outside of those are integers. And integers is with the z, kind of like that. It's basically kind of like two z's put together. So integers are negative. So negative numbers. So from like negative down to -3, -2, -1, 0, and then 1, 2, 3, and up. So it keeps counting up and keeps going down. So those are integers. So whole numbers and natural numbers are subsets of integers, but integers are not subsets of whole numbers or naturals. And then outside of that, we're looking at rational numbers. So rational numbers. So rational numbers are like, so that would be like 1/2 is a natural number, or 0.25 is a rational number. Sorry, rational. And then so 0.333 repeating. So it kind of is rational, meaning it's understandable, right? So if you have a decimal, it ends, or if you have a fraction, if you divide that decimal ends. But it also includes, so rationals also include all integers, all whole numbers, and all naturals, right? Because all these boxes right here are contained within this box. So that's why they're a subset. So it's kind of a way to look at a Venn diagram a little bit. So rationals include naturals, whole, and integers, as well as fractions that have decimals that either end or have a repeating pattern, right? So if it's like, let's see, if it's like 0.3, or say 2, 3, 2, 3, 2, 3, 2, and it has that repeating pattern of 3, 2, 3, 2, 3, 2, right? So as long as it has some type of explanation of how you can explain it, that is a rational. Irrational is on the other side. So you can't have rational and irrational at the same time. So irrational, our famous one is pi. Oops, that's not pi. It's pi. Or say a number that keeps on going forever. So 0.3233343536, and you keep on going in some kind of way like that, but it never ends and never has a repeating pattern. Is it 22/7? That's a close number to pi. 22/7, or square root 3, square root 2. Those are all irrational. Okay, and that's our real number system. So that's our real number system, and these are all the different sets of numbers that we have. So all natural, whole, and integers are subsets of rationals, but rationals and irrationals can't be joined together, so they're not subsets of each other. So real quick, talk about kind of exponents, the rules of exponents, right? Anything with a base raised to some type of number, so 2 to the 3, that's an exponent, or x to the 4th, that's as an exponent. And remember, so when you multiply by the same base, you add exponents, right? When you divide divide by the same base, you subtract. So I'll notice the base is both a. So then we subtract. When we divide, add, subtract. When we multiply, we can multiply exponents. When we raise powers to powers, we can multiply them. And then when we ever have a negative exponent, we can rewrite that as a fraction. So then we can bring anything a to the negative n over, say, b to the negative m. We can switch that to, so that's equal to b to the positive m over a to the positive n. So you can switch negative exponents like that anytime you have multiple. Whenever you have a product raised to a power, you can distribute that power to the exponents. And then if you already have one in there, an exponent within that product, you just multiply those exponents. So a to the m times n, and then b to the n times m. All right, so you just multiply, you distribute that. You got to be careful because that's not true when you do that. When it's adding or subtracting, it's only when there's a product. So you got to be careful though. But you guys have been doing this for a few years, so I'm sure you're good. But this does not equal a to the n plus b to the n. That's a common mistake. It's only when it's a product, meaning multiplication in here. All right, in order to simplify expressions, we have to know the order of operations. So we know, please excuse my dear Aunt Sally, or there's some other ones out there. So please excuse my dear Aunt Sally. But remember, when we do this, we look at parentheses. It's what's inside the parentheses that you're supposed to do first, right? On the outside of the parentheses, that's multiplication like this right here. That's multiplication. There's multiplication going on here. The parentheses mean do what's inside, not what's on the outside. And then we have exponents. So we have exponents next. And then multiplication and division. These are really the same at the same time. So if I have multiplication and division happening at the same time in my simplification, then I just go from left to right. I just do whichever one comes first, division or multiplication, because these are the same. Same with adding and subtracting. These are the same time as well. So whenever these are both happening, you just go from left to right. So whichever read your problem from left to right, and whichever one comes first, you would add or subtract. And then so this is basically use order operations when you're simplifying, and we always try to simplify our problems. And then if we ever have any types of fractions or anything like that that we're asked to simplify, we just simplify the top first and then simplify the bottom. And then we can see if we can actually divide. And then we have absolute value, right? Absolute value is the distance from 0. But we always have 2 answers. And why do we have 2 answers? And that is because when I'm on a number line, here's 0, right? Distance from 0. If I'm 5 away, the absolute value, say, is 5, I could go 5 to the right, or I could go 5 to the left. 2, 3, 4. So it could be at positive 5, or it could be at negative 5. So see how I have 2 answers here, because my answer could be negative 5 or 5. Both those have a distance of 5 away from 0. So when you're solving these problems, you're actually looking for 2 answers here. So that's why you usually separate these into actually 2 problems. That equals 0, and the opposite, right? So that'd be like 5, and then negative 5 is just the opposite, so then I also have the opposite one. So I take the opposite of this, which would be opposite of positive 2x is negative 2x, opposite of 1 is negative 1. And then I solve both of these equations, and then I have two different answers. So this was negative 1/2, x equals negative 1/2, and this one equals x is 1/2. Both of those are same distance away from 0. Negative 1/2 and 1/2 are the same distance away from 0. So to find the distance between 2 points, we can line them up on a number line. We can go negative 5, and then 8, and just count the distance, right? Or what we can do is take the distance of one point, say A, which might be negative 5, and another point, B, and that would just be the difference between the two. So either I take B, difference means subtraction, right? B minus A. I take the absolute value, right? Because distance is always positive. Or I take A minus B. So for example, if I want to find the distance between negative 5 and 8, I can either take 8, let that be my B, and minus A minus 5, and then take the absolute value of that, which is minus 5 is plus 5, right? Because I'm taking a negative, I'm multiplying. Negative times a negative is positive, is 13. Or I can take negative 5 and minus 8, which is negative 13. But then that's why I need that absolute value there, because then I get positive 13. So then I have the same answer. So that's how I find the distance between 2 points. I just subtract them. So that is it for this second R.2, or review section 2.